Good morning, students. In the last class, we discussed about comparison of EMFs of two cells by using potentiometer. Today, we are going to discuss internal resistance of a cell by using potentiometer. So, with the help of potentiometer, we are going to calculate the internal resistance of the given cell. So, potentiometer means the statement of the potentiometer is the potential difference across the length of a potentiometer wire is directly proportional to its length. So we discussed this point in the last class. So for example, this is a potentiometer wire. Then the potential difference across its ends of the wire is directly proportional to its length. So the potential difference across the length of the potentiometer wire is directly proportional to the length of the potentiometer wire. So that is the statement of potentiometer. And the internal resistance. So resistance means it is an opposition to the flow of current. It opposes the flow of current. That is nothing but resistance. Internal resistance of a cell means the cell itself opposes the flow of current. The cell or battery itself opposes the flow of current. So that is called internal resistance of the cell. So the definition is internal resistance refers to the opposition to the flow of current offered by the cell or battery itself, resulting in the generation of heat. Because the cell or battery itself oppose the flow of current. So due to the opposed to the flow of current, then what happened? Some electrical energy will be lost. So but according to conservation of energy, we cannot create energy, we cannot destroy energy, but we can change from one form of energy to another form. So because of this internal resistance of the cell, some electrical energy is lost. So that amount of lost energy will be converted as heat energy. And similarly, internal resistance causes drop in the source voltage when there is a current. When there is a current. If there is no current, then there is no the question of internal resistance. When the current is flowing through the cell, then only the internal resistance occurs in the cell. So finally, internal resistance of a cell means the cell or battery itself oppose the flow of current. So that is called internal resistance. Due to that internal resistance, some of the electrical energy will be lost, and that amount of lost electrical energy will be converted into heat energy. So that's why when the battery or cell is working, when you touch the cell, then you can feel some heat sensation. So the generation of heat is due to the internal resistance of the cell. So that internal resistance we are going to find out in this class by using potentiometer. So this is the experimental arrangement. So this experimental arrangement consisting of two circuits. One is primary circuit and other one is secondary circuit. So the primary circuit consisting of a cell or a battery B and a rheostat and a plug key and potentiometer wire. So from A to C, this is potentiometer wire. So K means it acts as a on-off switch. Rheostat means it is a variable resistor. We can change the value of the resistance with the help of this rheostat or variable resistor. It is a battery or cell. So it is nothing but primary circuit. And secondary circuit consisting of a galvanometer and a resistance box and one more key and a cell whose internal resistance is going to be formed. So these things comes under secondary circuit. Now the working is when the battery is on, then the current flows from positive terminal to negative terminal. So in this current flow, here you can find 2 points. So one is along the cell and another one is along the resistance box. Now here the functioning of this key roles play an important role whether the current is flowing through the resistance box or this cell. If this key is opened means it is in off mode. So when the key is open, then the current flows through the cell whose internal resistance is going to be formed. So when the key is open, then the current flows through the cell and that to galvanometer, and this is the jockey position. Now this jockey can be moved on the potentiometer wire. So while moving the jockey on the potentiometer wire at a particular point, that is point is called balancing point. So at that balancing point, galvanometer shows zero deflection. So at that balancing point, we should measure the length of the potentiometer wire. So that length is directly proportional to the voltage potential difference across this cell. So according to the principle of potentiometer, so the potential difference across the cell is E is directly proportional to length L1. Now in the second case, K should be closed. The key K2 should be closed. When the key K2 is closed, then what happened? The current flows through the resistance box. When the key is open, current flows through the cell, not from the resistance box. When the key K2 is closed, then the current flows through the resistance box. So in this case, current never passed through the cell. So when the key K2 is closed, then the current flows through the resistance box to the galvanometer and the jockey. Now the jockey can be moved on the potentiometer wire. So while moving the jockey on the potentiometer wire at a particular point, then the galvanometer shows zero deflection. So at that point, the voltage in the resistance box is directly proportional to the length of the potentiometer wire. In the second case, the length is taken as L2. So according to potentiometer principle, the potential difference in resistance box V is directly proportional to length. So this is equation 1 and this is equation 2. Now from 1 and 2 equations, equation 1 by equation 2 gives E by V equals to L1 by L2. So according to Ohm's law, V equals to what? IR. V equals to IR, Ohm's law. And E can be written as what? I into R plus R, where small r is the internal resistance of the cell. Now substitute these two equations in this one. Then what happened? E means what? I into R plus R divided by V. V means what? IR. IR equals to L1 by L2. So I will be cancelled. Then this can be written as R plus R by R. That means R by R plus R by R equals to L1 by L2. So again this can be written as R will be cancelled. Then the remaining term is 1 plus R by R equals to L1 by L2. Then shift this one this side. Then this can be written as R by R equals to L1 by L2 minus 1. Now take LCM. So what is LCM here? L2 and L1 minus L2. So therefore R by R equals to L1 minus L2 by L2. So this equation represents the internal resistance of a cell. So in this way we can calculate the internal resistance of a cell by using a potentiometer. Thank you.